Welcome to the Green Building Show, where we investigate green design and building trends throughout Australia.
I'm here today with Roy Yen and Dan Daly. Thanks for being with us, gentlemen.
Thanks,
You guys are part of the University of Wollongong's winning team who took out the solar decathlon in China with your Illawarra Flame home. Congratulations.
Thanks a lot.
So tell us a little bit about the home that you guys designed. We want to talk about the building elements that make up a home which has, optimal solar design principles. So what were the building elements that you really implemented in this home to really get that performance?
Well, our home was a demonstration of a retrofit of a fibro home, so we tried to stay as true to a retrofit as we could. So the home was a lightweight construction with wooden floorboards, stud frame and a Colorbond steel roof. And the upgrades that we made to it, basically we started from first principles of passive solar. We sealed the house, we insulated the house, we tried to incorporate thermal mass, upgraded the glazing, added some shading.
So really, you did it all. So
we did it all.
When it comes to lightweight, I guess what advantage does a lightweight home like the traditional fibro cottage have when it comes to improving its sustainability and its solar performance?
Well, the home that we had, I guess the biggest advantage of it is that anything you do is an improvement, because it was a really poorly performing house to start with. So you do get a lot of bang for your buck when you make improvements to that kind of house. So.
Okay, but with a lightweight home, is it perhaps easier to install the insulation rather than if it was a brick home or something?
Absolutely, yeah. That's absolutely correct. So given that we were making some structural changes to it and we were pulling off the cladding, it's very easy to then insulate that because we have the studs exposed, so you can put in insulation in between the studs and then external to that as well.
Okay, great. And Roy, what kind of thermal mass was put into the house, and where was it put into the house, and what were the benefits of that?
In our house, we just have a thermal mass wall in the living room because it's considered a competition like a scenario. Like we will open the house in the daytime, like in the summer, whole summer, which will also absorb lots of heat. So we just have like a crest, terracotta thermal wall in the living room. Okay,
so would a home like this traditionally be on a concrete slab? Did you take that into account?
No, that will be like on floorboard.
Right, okay, great. So no thermal mass in the floor, but you just implemented some in the walls.
Yep. Yeah, but in reality, we want to put more thermal mass in the house, through our computer simulation, put more thermal mass in the house will be benefits to the energy efficient of the house.
All right, and where I guess in your opinion, what's the easiest place to insert thermal mass into a home?
Well, you can put the thermal mass in really wherever you want, and there's different things you can use. I mean, you can use traditional materials like putting in some concrete slabs. In this case, the house would have been on brick piers most likely, so putting a concrete slab on or exposing the concrete slab wouldn't have been realistic. So if we were doing this in situ, we probably would have gone down the similar road that we went down, but just putting more thermal walls in and possibly some floor elements as well of a similar construction. Another option is to use more modern materials like phase change materials, which are much more lightweight but perform in a similar way to thermal mass to regulate the temperature.
Okay, great. And how did you retrofit the insulation of the home?
We first put rock wool, it's called knolf, earth wool into the cavity of the wood frame, and we put the PIR onto to provide an extra layer of the insulation. Okay. And we reach about R5.5 to R6 of the total R value of the wall.
No, we actually improved it from 0.5 to 5.5 to 6. So
Oh, wow.
it's like a tenfold improvement essentially.
Oh, fantastic! And
Yeah.
so did the theoretical existing house have insulation currently?
No, it wouldn't have. That kind of house would have
Right,
been
okay.
totally uninsulated.
So I guess someone it's for the average Australian homeowner, say they had some insulation in the house, but perhaps not enough. How would you advise them to go about retrofitting the insulation in the house? Does it make sure put it in the floor as well as the walls, put it in the ceiling, put it in the sarking? Can you give us a bit of a rundown?
Yep, the general way to go is from top to bottom, so roof, then walls, then the floor.
So the roof is the most effective?
The roof is the most effective, yeah, because as hot air rises, so you're getting a lot of heat escaping through the roof. But it in often cases comes down to a case of economics based on what the structure of the house is and where you can most easily get access to, because insulating any area of the house is going to lead to some improvements.
Right, okay. And when you say improvements, I guess what kind of improvements, can you give us an idea? I mean, these R values, they don't particularly mean much to me.
Sure.
I guess what do they mean in terms of comfort? If you improve your house, 0.5 of an R value, what's that going to mean for your lifestyle?
Well, so the R value essentially means how much heat is escaping through a wall element. So by improving the R value from 0.5 to 5, say, we're allowing 10 times less heat to enter or escape through the walls.
Right.
So if we had a mechanically ventilated building, which in our case we did, then we've reduced the load on the air conditioning system by tenfold. So you essentially could have a 10 times smaller air conditioning. And yeah, if you don't have an air conditioning system, then you're going to get improvements in comfort, but it's hard to quantify comfort.
All right, great. And Roy, did the choice of materials that you used in the Illawarra Flame, was that a key aspect of the design and the way you built this home?
Yeah, like choosing the material, the key design. So we choose the materials basically from two aspects. Firstly, from our simulation. So because this house focus a lot on the energy saving, so we did lots of simulation about different materials impacts on the energy performance of the house. And another aspect, we are using the a criteria called the living building challenge. From that that may be called a challenge or competition, or maybe not competition. It's defined lots of requirement for the materials. There's a list called red list, when some kind of the material is blocked, like PVC pipe and some other things, and also it requires you lower the embodied energy of the materials. So we need to find our material mainly from local.
Okay, so it's all locally manufactured stuff.
Where possible, yeah.
Sure. Okay. Great. All right, fantastic. Is there anything I'm missing here in terms of your building elements and making the most sustainable and optimally designed home for passive solar?
One of the key features of a house, and probably one of the things that really helped us in the competition, was we used a whole lot of recycled hardwood. So we had some of our team members go out to a local house that was being demolished and strip out hardwood from the frames and the floors and denail it and put it through the mill, and then we reuse that. So we ended up reusing about 2 kilometres of
Wow.
hardwood, which was a big job.
How did you choose the e-coating for the windows for that particular climate? How did you know it was appropriate?
Yeah, we're still doing from the simulation. It's 2 parameters determine the performance of the window. One is the U value, one is the solar heat gain coefficient. So we tested different parameters of the windows and have looked the energy performance of house and determined the U value to be about 1.1 to 1.5 and solar heat gain coefficient about 0.3.
Thank you so much for your time, gentlemen.
Yeah, no worries. Thanks for having us.